Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 4 of our color switch series which we're making on Scratch 3. In case you've not watched parts 1 to 3, I will leave a card for you right here. By the end of this video, you will be able to create the most sophisticated double obstacles of the level. You'll also be changing the coding format into a much more productive one compared to what we have right now. The new coding format will be very useful when we add in additional game features in the later parts of the game. You can begin by heading over to the obstacle sprite, and once you're there you can set up a couple of functions, 6 in total. The first one will be called double circle, the next one will be called circle plus, the next one would be called circle box. Once you're done with these, you can follow them up with the box circle, then the box plus, and finally the double box. You should be able to intuitively understand what I'm trying to do here. These things are going to be clones as usual, but these things are going to be special obstacles, which means they're not going to have a single obstacle, but an obstacle within an obstacle. So we'll be having, for example, for double circle, a circle within a circle. If we were to take another example such as the box plus, we'll be having a plus inside the box. These things would really spice the game up and make it a lot more fun to play. Let's now get into the functions, starting with the double circle. You can copy and paste all of the small circle code into the double circle, but we will need to make quite a few changes. First of all, let's make sure that the obstacle clone Y is changed by 90 on both ends, because this is the big circle and not the small circle, so we need quite a bit more space. Once you're done with this, you can also remove the direction randomness. This is because all these double sprites need to be pointing in a specific direction to make sure that the two rotations align. So think about it, since we have a sprite within a sprite, or more accurately an object within an object, one of them is going to be rotating in the clockwise direction and the other one is going to be rotating in the anti-clockwise direction. At some point we need to make sure that the player can move through both of them. To make sure this happens, all of this needs to be pointed at a particular direction right at the beginning. So make sure you point in direction 60. Next, set the double value to be yes. This is because we need to make sure that sprites which have doubles, which means one object in the outer and one object in the inner, have this value set to yes. Next, you can also make sure that the rotation speed is aligned, because for all these double sprites, the outer object is going to be rotating a lot faster and in the opposite direction of the inner object, which means the inner object basically needs to rotate a little slower if we want the user to actually be able to perceive the outer object moving. So 1 works as a pretty good value, so make sure both the positive and negative rotation is changed by 1. Okay, now you can copy and paste the code from the set costume 2. You can remove the set x2 right after you do that, and then you can set the costume to be the big circle. This is because the big circle is going to be the outer object in question. Set the rotation speed from 1 and -1 to be -3 and 1. And that should be all we need to do for our double circle. You can now copy and paste all of the code from the double circle into every one of these new functions which we've created. This will make it very easy when we proceed instead of starting all over again. Within the circle plus function, you can first change the direction from 60 to be 0. Then you need to make sure that the rotation speed is adjusted and set to 2 instead of 3. Once you're done with this, you need to make sure that the x's are aligned. So set x to 30 when it's rotating in the positive direction and set x to -30 when it's rotating in the negative direction. We don't really have to make any changes in the second part of the function. We can simply set the x value to be 30 and -30 for the two r values, and we should be done with it, and now we can move on to the next function. As far as the circle box is concerned, all we have to do is to change the direction first, which means setting it to 90. Then we can change the costume to be the small box. Following this, we can make sure that the boxes rotate in 2 different ways for their 2 different R's, just to make sure that it aligns perfectly depending on its rotation. In the first case, we can rotate by -45 degrees in the clockwise direction and in the second case we can rotate by positive 45 in the clockwise direction. The second part of the code is going to basically be remaining the same, so you don't have to make any changes there. Once you're done with these things, you can move on to the next function. For the box circle function, you can start by changing obstacle clone y by 120. Then you can go to the second part of the function and change the costume to the big box, and finally changed obstacle clone y by 120 once again. Now you can move on to the next function. In the box plus function, you can first start by changing obstacle clone y by 140 on both ends. This is because the size is also going to be changed for these two objects later on. Once you're done with this, you can point in direction 0 in order to make sure that the alignment works well, and then you can go to the R where we're setting the rotation speed and set it to 2 instead of 1. Next, we can make sure we align X to 30 in case the rotation speed is positive, and we can align X to be negative 30 when the rotation speed is negative. We can finally change the costume for the first part of the function to be the small plus. Within the second part of the function, we can make sure that the costume is changed to the big box. Once you're done with this, you can align X to be positive 30 for the negative rotation speed and negative 30 for the positive rotation speed. Now, like I mentioned, if the current default sizes are used, then the plus is actually going to be hitting the box. Since we don't want this to happen, we can make the box a little bit bigger than it otherwise would be by first changing the size to be 120, and after we're done creating the clone, we can set it back to 100. Okay, so now we can head over to the final big box function. Let's start off by changing obstacle clone y by 140, because in this case as well, we'll be enlarging the big box. Next, you can go ahead and change the direction so that it begins at 30. This will ensure the alignment. Once you're done with this, you can change the costume of the first part of the function to be the small box. Once you're done with this, it's important to make a crucial change for this particular function with regards to the rotation speed. So in case we let these boxes to rotate at their standard rotation speeds, which is what we did for the other functions, then this is actually going to be way too fast for the user to get through. What we need to do therefore is to keep the proportion of rotation between the two boxes the same, but we need the boxes to rotate more slowly. To achieve this, we can make sure that the rotation is being changed by 0.83 and negative 0.83 for the first case. For the second half of the function, we can first change the costume to be the big box. Then we can make sure that the sizes are being changed. We can start by setting the size to be 120 and then back to 100 after we've created the clone. Finally, to make sure the rotations stay in proportion, what we can do is change rotation by negative 2.5 and positive 2.5. Alright, now we're done defining all of the functions, and we can actually go ahead to the create clones function so that we can start using them. Just like the previous obstacles, these new obstacles are going to be assigned a number as well. The double circle is going to be 17, the circle plus is going to be 18, the circle box is going to be 19, the box circle is going to be 20, the box plus is going to be 21, and finally the double box is going to be 22. Now you can start stacking up if then blocks. Within the condition, we can check if block is equal to a certain assigned number, and if it is, we can create the obstacle based on that assigned number. Once you're done with all of this, you can start to head back up and actually change the repeat from 6 to 12. Since we know that there are 12 different ways of creating obstacles, this will make sure that all of the obstacles are created at least once. While this code will result in getting us the output that we need, it really isn't helpful for proceeding forward. This is because in our completed color switch game, we'd want to keep generating levels even after the existing ones are finished. Now we could do it with this code, but we'd have to do it only in this particular order, and we also cannot change the way this is done. We cannot assign any kinds of probabilities for forming the different types of obstacles, and this makes us very handcuffed. In order to fix this problem, we can make use of cloud variables and store basically our entire level in two of them. So just follow me along right now, and once we get to a substantial point, I'll explain why we're doing it this way. You can start by creating two new cloud variables. The first one is going to be level, and the second one is going to be level rotation. You can uncheck both of those checkboxes in order to make sure that they hide. Next, you can make sure you set level to be numbers from 11 till 22. Now this obviously represents the number values that each of our obstacles have, but more on that later. Regarding the level rotation, you can set it to be a random series of 1s and 2s. Just make sure that before every 1 and before every 2, you add in a 0, because this is crucial in order to make this work. You can set it to be the same length as our level, so that for every 2 numbers in the level, there are 2 numbers in the level rotation. You can click those joint blocks once in order to make sure that they apply. You can go back to the create clones function, and once you're there, you can throw in the set block to line into the repeat. Next, you can start to transform the abstract numbers which are in the level into some actual tangible clones. Think of it the following way. Take the level variable as it is with all of its digits. Now using a counter, what we can do is select 2 of its particular digits and take them out in isolation. Once we're done with this, we can use the number values of the functions which we've just created and convert this particular number into one of the obstacles. Once we're done with this, we can simply move on to the next 2 digits of the level using the same counter and do the same process again. We can repeat this as long as we want, which is basically going to be until we've created the number of clones that we want to create. Getting back into the code, we can now create the variable which will act as our counter, which is going to be called obstacle item number. You can create it for all sprites with caps and then click OK. It's important to set this up at the beginning of the game when we receive init. So what you can do is head over into the backdrops and do it there. I will be changing this counter by 2 before we actually start to use it, because it's going to be convenient when we end. So what I'll do is, instead of setting it to be 1, I will set it to be -1. You can get back into the create clones function, and once you're there, you can change obstacle clone y by 2 right at the beginning but inside the repeat. All we have to do now is make sure that both the block and the C1 are basically set to the corresponding counter values from the level and the level rotation. We can actually go through this step by step. The first digit is going to be the number which is situated at wherever the counter is at the level. This will be represented as a letter obstacle item number of level. Given that we know this, the second digit should be fairly straightforward. It is simply going to be whatever number is right next to the counter which we already have. We can represent this as letter obstacle item number +1 of level, and this should do the trick. We can duplicate all of this into C1 as well, but since C1 is going to be taking in the direction with which the block should be rotating with, we basically just need to take it from the level rotation instead of the level. Now once you've put this in place, that is all you need to do. You can test out your code right away, and if you've been following this video with accuracy and you didn't make any mistakes, your code should be working pretty perfectly. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.